Hello everyone, in this video lesson you will learn how to find all roots of any polynomial. That means real number roots and also complex number roots. So a quick review for imaginary numbers, which is also complex numbers, is so if we're given this equation x squared plus 9 equals 0, and when it's solved for x, we would subtract the 9 from both sides of the equation, or just move the 9 to the other side, which means we subtract it. So then we have the new equation is x squared equals negative 9, but then we want to get the x by itself, or x not x squared, so we take the square root. But don't forget, this number is negative, so then this number is not a real number. Okay, so this is imaginary or complex number. So then when we take the square root, then we have the absolute value of x equals plus, or in this case, not plus or minus yet, just 3i. So the square root of negative 9 is 3i. But once we remove the absolute value, then we have to say x equals plus or minus 3i. And this was covered in the beginning of the fall semester of this year. So it has to do with the index being even and the power of whatever is coming out of the radical is odd. So this is a first power. So then that's why we include plus or minus. And the same reasoning goes with this one here. You have plus 4, so move the 4 to the other side, which means you subtract the 4. Then you take the square root of both sides of the equation. So then we have that the absolute value of x is equal to i. And when we remove the absolute value, that means x equals plus or minus 2i. So this is a quick review on how to solve equations that include complex numbers. Okay, so we'll be using this today throughout this lesson. So let's go into the first example. So we have a 4th degree polynomial. Okay, we're going to find the real roots using a calculator, and then we'll find the complex roots after that. So let me take you to the calculator. So I've already entered, for the sake of time, the equation here, the polynomial. And I'm just double checking that everything is correct, because if this is incorrect, then I'm going to get something that's incorrect. So just verifying everything seems to be correct. So then I'm going to graph it. And when I graph it, I'm going to pay attention to where I see the graph crossing the x-axis. So we see the graph crossing the x-axis at negative 1, negative 2, 3, 4, 5. So negative 5 and negative 1. So we have real roots, and we can actually verify these roots. Okay, so I'm going to press second trace, and then let's say a value. Okay, so value, just leave it at 1. So I want to check when x is negative 5, see if that gives me 0 for y. So negative 5, I'm going to enter that here, and it gives me 0 for y. So that means this solution is a real solution. Then I'm going to press second trace again, and value again, so 1. And now I'm going to test negative 1. So negative 1, if I get a 0 for y, that means that is correct, right? So I do get a 0. So then the other solution is negative 1. So once we have two solutions from the previous lesson, we can use synthetic division. So I'm going to set this up with synthetic division, which means we have, I'm going to use negative 5. Okay, and then look at the coefficients of the polynomial. X to the 4th is 1. X to the 3rd is 6. X to the 2nd is also 6. X to the 1st is 6. And the constant is 5. So in the end, we should have a 0 remainder in that box. So then I'm going to drop the 1, start multiplying with synthetic division. Negative 5 times 1, that's negative 5. 6 minus 5 is 1. Negative 5 times 1, negative 5. 6 minus 5, 1. Negative 5 times 1 again, that's negative 5. 6 minus 5, that's 1. And negative 5 times 1, that's negative 5. So then this becomes 0. So this one here, this is the 4th degree, right? Which means the next one here, this is the 3rd degree. So now we're down to a 3rd degree polynomial. So then we use the other solution. So I'm going to continue applying synthetic division. So then the other solution is negative 1. So then let's start multiplying, and in the end we should have a remainder of 0. So negative 1 times 1, negative 1, this is 0. Negative 1 times 0, that's 0. This becomes 1 plus 0, which is 1. Negative 1 times 1, negative 1 again. 1 minus 1, 0. So this one here is a second degree polynomial. Okay, so notice that this is this is the x squared because that's the first term, and this is plus, this is the linear 0x and then plus 1. So then we set this equal to 0. So this just simplifies to x squared plus 1 equals 0. So now what I'm going to do is what I did with these two examples. Okay, I'm going to move the 1 to the other side of the equation, which means I'm going to subtract 1. So then we have that x squared equals -1. Since I want the x, not x squared, then I'm going to take the square root of this side and the square root of -1. But don't forget, this is the definition of the number I, right? So then this means that the absolute value of x is equal to I, which means that x equals plus or minus I. So there we have the complex roots. So in the end, the solutions to this polynomial, this fourth degree polynomial, is x equals -5, -1, and plus or minus I. So there we have the 4 roots for that polynomial. Okay, so let's move on to the next example. So for this one, again, we're going to find the real roots by graphing the equation in the calculator. So I have entered the equation or the polynomial in the calculator in y equals, then I'm going to graph this equation. But again, double check that everything's entered correctly, and I've double checked this so everything is correct here. So then I'm going to graph it. And when I graph it, when I graph the function, I see that there is a bounce at -1, 2, 3, 4. So -4, and then another crossing of the x-axis at x equals +2. Okay, so then just to double check, second trace, let's check the value. So let's enter -4 for x, and let's see what it gives us for y. So I'm going to press enter, and it does give us a 0 for y, right? So that means x equals -4 is a double solution. So this one is a double, which means we get to use it twice with synthetic division. And the other solution is, let's test it again. So I'm going to press second trace 1. We want a +2. So enter 2 and then press enter, and it gives us a 0 for y. So then the other solution, we see that it's a real number is +2. So then let's set up synthetic division. So let's start with -4. Okay, that's the first one. We get to use it twice because it's a double solution. Coefficient of x to the 5th is 1, x to the 4th is 6, x to the 3rd is 3, x to the 2nd is -14, and x to the 1st is 0. There's none, so we need a placeholder. And then the constant is the number -96. Okay, so then let's start applying synthetic division. -4 times 1, -4, 6 minus 4, that's 2. -4 times 2, that's -8. 3 minus 8, that's -5. -4 times -5, that's +20. -14 and 20 combined to 6. -4 times 6, that's -24. 0 minus 24 is -24. And -4 times -24 is +96. -96 and +96, 0. So there is, this was the fourth degree. This is the third degree. Okay, so again, we get to use -4 one more time because it's a double solution. So then -4 and then drop the 1, start multiplying. -4 times 1, -4. 2 minus 4, that's a -2. -4 times -2, that's a +8. -5 and 8 combined to 3. -4 times 3, that's a -12. 6 minus 12, that's a -6. -4 times -6, that's +24. -24 and 24 combined to 0. So this is the third degree, right? No, this is the fifth. This is the third, and this will be the second degree, right? I'm getting messed up here. So anyways, let's see. So this is the fifth degree, the fourth degree, the third degree. So this is the third degree. We get to use now the other solution, which is +2. Then let's apply synthetic division. So 2 times 1 is 2. -2 and 2 combined to 0. 2 times 0, that's 0. 3 and 0 combined to 3. 2 times 3 is 6, and -6 plus 6 is 0. So then we have, this is a quadratic, okay? So this is fifth degree, fourth degree, third degree, and second degree. So that means x squared plus 0x plus 3 equals 0. So I'm going to just write down +3 and set it equal to 0. and then we solve. So we're going to find the complex roots. There's going to be 2 of them. So what I'm going to do is I'm going to move that 3 to the other side, which means x squared equals negative 3. But then I want x, not the square, so I'm going to take the square root to cancel the square. So then the absolute value of x is equal to, I'm going to pull out the I. So factor out, take out I from the square root of 3, right? So that negative is the I. And then this means x equals plus or minus I square root of 3. Okay, and this was explained in another video, and I hope you guys remember. So we have the real solutions and the complex solutions, so roots. So then the roots are x equals negative 4, and this one is a double solution, and we got that from the calculator, and we verified, and then positive 2, and then the ones we found algebraically, plus or minus I square root of 3, and that is all for this problem, and that is all for this lesson. I'll see you guys in class. Bye-bye.